Mm, ok. Bueno, ya estamos en vivo. ¿Ya estamos? Vamos a verificar que estamos en vivo. Ah, sí, ya. Tan, tan, taran, tan, tan. Y el día de hoy vamos a seguir. Oh, I'm supposed to do this in English. I forgot about it. Uh, so today we're going to continue working on. There we go. We're going to continue working on Python programming and learning Python. At the moment, I'm working on the basics. So let's make some changes over here. I really need a bigger desk, and I have a pretty big desk already, but maybe I just need to put some order here. But anyway, today is Sunday, May 1st, 2022. And we do have a holiday in Mexico called Work Day. It's a special day because nobody works. So we were lucky enough to have it this year on a Sunday, so we don't work either way. So I guess it's ironic, I guess. Let's see. So yesterday, I end up with Docker strings. Pretty interesting video. Basically, I need to take into consideration that creating these Docker strings at the start of the functions or the scripts maybe is going to be very helpful, especially for functions and methods, because I am able to basically explain in a very short manner how the function is supposed to be working. And I am a really fan of technical documentation that I can actually update whenever I go into this source code, Clean code, what was this about?
I want to talk quickly about the idea of clean code, something that we've talked about before. And this is a good example to do with something like a function. For example, let's say we had a function that perhaps checks if a number is even or odd.
Oh, so yeah, I think I remember.
Get to line 5 if the statement is not correct. So the result, as we...
Yeah, this was like a short video about refactoring and how to simplify things. Refactoring is one of those things that you either learn by experience very slowly, or you just get somebody to teach you basically from a book or a video course. And I've been learning refactoring from both books and video courses like this one. I really recommend refactoring anyway. So yeah, clean code is going to make the code more readable. It's supposed to make the code readable, and it's supposed to make it easier to understand basically, and to update. Okay, next, args and KW args, I guess arguments.
Let's talk about something called arguments and keyword arguments. I mean, we've already
keyword arguments, okay.
With a function, we actually have the special characters that we can use called args and keyword args. How can we use these? Well, let's have a look. Let's try and have a function, let's say define, and we'll call this a superfunc for superfunction that receives some sort of arguments.
Okay.
And these arguments that we're going to receive, and remember, although I'm calling these args, this itself is a parameter, remember?
But yeah, it's just one variable, one parameter
of the arguments. And you might be wondering, wait, don't we have to define that function? Well, sum actually exists in Python, as you can see over here. So we can just return the sum of the arguments. So let's try this. Let's say superfunc and give it arguments 1, 2, 3, 4, 5. If I click run,
no,
I get
because it's a collection.
Superfunc takes one positional argument, but 5 were given.
Yeah.
And that makes sense, right? Like I only have one parameter here, which is a positional argument that it accepts, and I'm trying to sum this. So it only receives one, but I'm giving it all these things that it doesn't know about. And this is where
I know what that is.
By adding a star to here, we're saying, hey, this can accept any number of positional arguments like this.
Okay.
As many as I want. As a matter of fact, let's print this out. If I do print star args, and we run this function, we see that the print star args gives us 1, 2, 3, 4, 5. These are all the parameters or the arguments that we get. And if I actually remove the star here and click run, look at that. I actually get this as a tuple. So args inside of this function is a tuple of arguments that I give it, 1, 2, 3, 4, 5. So sum of the tuple 1, 2, 3, 4, 5 is going to give us the right answer. It's going to print for us the answer 15. Very, very cool. So this way we can extend and use our star args to have a function that can accept any number of arguments. So what is this one now? Well,
so it's a pointer, basically.
Allows us to use keyword arguments. For example, let's say I have the star star keyword args like this. And by the way, this can technically be anything. So this is a variable that we're creating, so I can name it who if I wanted to. But the standard is to name it args and keyword args because other developers are using it this way, and it's just the way it's done in the Python community. Now with the keyword args, as you might have guessed, I can add keywords like num1 equals 5, and then num2 equals 10. So that if I print the keyword args and I click run, I get a dictionary of num1 equals to 5 and num2 equals to 10. So I can actually do something like sum plus sum of items in the keyword args and grab the values, right? You've seen that before. And let's actually grab this and do a for loop and say items in keyword args dot values. Remember to grab the values over here. And in here, just add up the totals. So let's say that in here, total equals or plus equals items. And we'll add a total in here that is initially 0. So that sum will be sum args plus total. If I run this, I get 30, which looks about right. Now, this does look a little confusing.
Plus
let's go over
15,
We have the star args, which allow us to grab these positional arguments and just sum everything. And we also have keyword args, which allow us to grab any number of keyword arguments and get a dictionary, which comes as keyword args, and then use them however we want. In our case, we're looping over all the values, so items in keyword arg values, and then I'm just going to total all those items, have a total, and just return the sum. Now, this is, again, extremely useful because our superfunc can now take as many arguments, as many positional and keyword arguments as we want. Now, one final thing. There is a rule of the ordering that we can do of our parameters here, right? So the rule is this. First, in our parameters, we have, well, our actual params. Then we can do star args, then default parameters, then star star keyword args.
That's important, actually.
Let me show you what I mean. If we want to define this function, we want to make sure that if
invert the order.
Let's say name, that should come before star args.
And if
that's we have default parameters, that should usually come after args, but before keyword args. So if I do, let's say I equals hi, and make sure we have a comma here, we now have followed the rule. And by the way, you would never actually write a function
legal.
Because, well, frankly, it looks super confusing.
Legal
usually
syntaxes.
Only using 2 of these, or maybe just 1 of these. But this way, I can call this function with name, Andy, then my args, then my default parameter, which will be I equals to hi, which let's say we don't even pass in. And then we have this. So if we run here,
then keyword args.
This still works. We are just not using name and I. We see that I'm following the rule of params, args, default parameters, and then keyword args. All right, hopefully your head doesn't hurt too much after this one. Take a break, and I'll see you in the next one. Bye.
Wait, I actually want to test something here, or several things here, because I had seen something similar in Java where you can actually do this pretty much the same thing with the condition that you need to, your list of any number of parameters needs to go at the end of the parameter list, basically. So you're not allowed to do it just like this. So let me try something here. Okay, let's say def superfun and semicolon at the end, and let's say I'm going to take just like him, nums. Okay, so this is going to be what was the order again? Okay, rule are params, regular params, args, default parameters, and keyword arguments. Let's try keyword arguments first, because that's keyword arguments. Okay, so let's say I wonder if I can just print it out. Keyword args. Super fun. And I wonder if I can, what's the collection? I wonder what type of collection is this going to be? So let's see, name equals, I don't know. And let's say age equals 23, something like that. So what's that going to do? Huh. So it's a dictionary. It makes sense, I guess. I guess I can, in that case, I assume I can pass a key with another collection inside. Like, for example, friends equals, what? It's not, it's a Spanish from Spain. It's not a Spanish from Latin America. Okay, there we go. Okay, friends. So I guess I can basically create a list of friends. I don't know. Let's say Lisa, Mary. Oh wait. And John, something like that. I don't know. And just as expected. So this is a dictionary. So that's the collection that this is going to. All of these keyword arguments are going to land on. So what happens if keyword arguments are supposed to be at the end? So what happens if I don't do that? What happens if I do like I equals to 1? You know, oh, I see why. Because it's going to think that this is just another key argument. I guess that it's going to break if I don't actually assign it a value. There is going to break. That's why. Oh, okay, I get it. Yeah, it makes sense. It makes sense. So I may need to put it right here, for example. Before, there we go. Oh, wait a minute. It still believes. Yeah, because I didn't. I'm not passing another argument at the function, so it's okay. So y, comma. There we go. Let's see if we can print I. There we go. I can actually assign a value at execution time. 3. Positional. There we go. I can print the value of y, of I. There we go. So what's the order again? And before that, keyword arguments, default parameters, arguments on args. Okay. Okay. Default parameters. Let's put it right here. What else can we do? It's already midday? No, close to. Okay. Wow. Time flies here. What else can I say? Okay. Keyword arguments, default parameters, arguments. Okay. So this is pretty, I guess that these are basically pointers, because the syntax looks pretty much like pointers. And I just put the variable there. Okay, args. There we go. So that means that if I do, oh wait, is that going to work? No, it needs to go like this. It doesn't need, it cannot be positional anymore. It needs to go like that. I wonder what's gonna happen here. There we go. Yeah, it cannot be positional anymore. So, okay. Because I guess that if I do this, it's going to think, yeah, that it belongs to the list of arguments, and I is going to receive the default value. So I need to name it clearly here as I. Okay. And there we go. Actually, it seems like it's creating a tuple with 2 values. It doesn't matter that I'm just using 1. So let's see what happens here. There we go. So that's going to be a tuple. There we go. Next, I'm getting the arguments, the default parameters, and then I'm getting the keyword arguments. And before that, all the arguments, what happened before that. And the first thing is regular parameters. Okay, so I guess regular 1, regular 2. There we go. So what happens here, I guess, in the same fashion, I need to assign, this cannot be, okay. So this, let's say that 1 is going to be regular 1 equals to 1, and 2 is going to be regular 2 equals 2. And 3, let's say 3, 4, 5. To say something. Wait, I'm missing a semicolon here. Oh, wait. Equals to 2. Regular 1 equals to 1. Regular 2 equals to 2. Then we have 3 here. Positional argument follows keyword argument. Yeah, is that wrong? Rule is params first. Yes. Oh, wait. I cannot assign default parameters there? No. So their positional arguments follows keyword argument. So this may not be, but he does have, okay, let's see. No. Wait a minute.
Usually you're only using 2 of these, or maybe just 1 of these.
Okay, he's using name, but he's not actually calling it like that. Rule params is args, default parameter. Where is params though?
But this way, I can call this function is this. First, in our parameters, we have, well, our...
Did he run it? No.
Now take as many arguments, as many positional and keyword arguments total. If I run this, I get 30, which looks about right. Now, this does look a little confusing, and just return the sum. This. First, let me show you what I mean. Say name. That should come before start args.
Do you run that?
Parameters, that should usually come after args, but before keyword args. So if I do, let's say I equals hi, and make sure we add a comma here, we now have, following the rule, and by the way, you would never actually write a function like this because, well, frankly, it looks super confusing. Usually you're only using 2 of these, or maybe just 1 of these. But this way, I can call this function with name, Andy,
okay,
then my args, then my default parameter, which will be I equals to hi.
Yeah, he's doing it just like that. Probably I should just try something like this, maybe. There we go. It's actually valid. Okay. Let's try to print them out. Regular 1. Probably concatenate a white space or a comma here. And then regular 2. There we go. Okay, this actually works. So as long as I remember the rule, which is params, args, then default parameters, then keyword arguments. Yes, this is going to, keyword arguments specifically is going to be great because I tend to work with dictionaries a lot, and passing by values one by one is complicated because these objects tend to change a lot, and if I try to force a structure, it's really hard to pass arguments like in a structured fashion all the time. So this is going to give me the flexibility I need to create objects, especially when I'm working with web applications, when I'm sending and receiving objects all the time from in JSON format. I can. Okay. Okay. ¿Hay café? ¿Me traes café? ¿Necesitas café? Voy. Bueno, voy a bajar. ¿Hay café? Okay. Anyway, let me check. I'm looking for interesting people into. Oh, why? Why do NoSQL developers is launch alone? I don't know why. Oh, yeah. Yeah, that's actually a good joke. What introverts can you make? Oh my god. Okay, nothing interesting. Where were we? Oh yeah. As long as I remember the rule, params, then args, then default parameters, then keyword arguments. Everything is going to be fine. Exercise functions.
Let's combine everything that we've learned into this challenge. What I want you to do is to create a function called highesteven, and this function is going to take a list data type. And this function, for now, will just pass, but I want you to fill in this part with whatever you think is going to allow us to achieve this. If I do print highesteven, and I give it a list of, let's say, 1, 2, 3, 4, 8, I want the highesteven to be printed in this list. And actually,
what's the highesteven?
So the highesteven number in this list is 10. Just for fun, let's add 11 as well. So the answer should be printed here as 10. So based on everything you've learned so far, try to fill this part so that you create your own function.
The highesteven number. No, these are two things. Oh, okay, that's an even number. And the highest value from those. Okay, I get it now. So what he's asking here, can I, but that's the solution. Well, it's not a big deal. I can just, okay, def highesteven, and it's going to receive a list. Okay. Def, I don't know how to type that. Hi, H-A-S-T. Hi. I'm missing a E over here. Wait, what's that? Even. And he's receiving a list. Okay. He's getting a list of numbers. Well, I guess that I can use numbers list, something like this, and receive it as args, you know, so I can receive any number. Oh wait, if I do that, I'm going to get a tuple, and tuples are, well, let's just get as a regular parameter then. Who cares, because I'm going to receive a list anyway, so who cares. He did this, so let's okay, so parameter is going to be a list. Going to be 1 2 3 4 5 6 7 8 9, something like that. Okay, so that's the parameter I'm going to use. And there we go. So that's what I'm supposed to do. Okay, I'm going to print this one out. and whatever this returns, return the highest even number. Okay. Okay, the first thing will be to get all the even numbers. So in order to do that, if I already know that numbers list, this thing here, this argument here is already containing a list of numbers, then I'm not going to validate if the data type is correct or not, because it's a list, so it may contain even text, it may contain Boolean values and numbers. So I'm going to guess that unless I learn already how to appropriately work with exceptions, which it's not my case. Well, so I guess I'm not going to think about it anymore. Anyway, so I don't know how to deal with error handling yet, so I'm going to skip that part. What I'm going to do is I'm going to navigate through this list and divide the number itself between 2, get the modulus, and if that's 0, then I don't know, then maybe create a new tuple and get the highest value there. I don't know. Okay, so let's just move all those numbers to a new list maybe, and see what happens. Okay, so okay, even numbers. I wonder if it actually matters that I initialize this variable like this, because I don't specify types here like in a hard-coded language, but I think it's really useful to initialize data types this way. I guess it works for me on JavaScript. So okay, I initialize in a new list here, even numbers, and now I'm going to get all the even numbers here. So how do I do that? Well, let's say that even numbers dot append, and I'm going to put the value here. In this case, it's going to be, oh wait, I'm not even on a for loop. Okay, for let's say number and numbers. There we go. For one number in numbers list, semicolon. Oh wait, the function doesn't have semicolon either. Okay, so here I want to append something. I need to ident this a little bit further. There we go. And what I'm going to say is, okay, append this number, but I'm not going to do that all the time. I need to ask if the number I'm going to append is an even number. So in that case, I'm going to ask if, so do this, I mean, append to the even numbers list the current number on the numbers list if, and this is where I'm going to put my condition. And the condition will be if number, how do I get the modulus here? I forgot. Module operator, thank you. Okay, so it's like in C or Java or JavaScript. Okay, it's the same thing, I guess. Let's see an example. What? Modulo, how to use the operator. Okay. We didn't. There we go. That's pretty simple so far. I'm going to divide it by 2. Is this equal to 0? So this means that if I divide the number by 2 and the remainder is 0, then that means that this is an even number. Okay, so if not, else, continue. Can I do this? I cannot do that. Why? Invalid syntax. What did I do here? Maybe I can just do that. No, it needs to end, isn't it? Okay. Okay, I wonder if I can just skip. No. No. Ternary operator syntax. Thank you. Need a refresh. Okay. Okay. True val if condition else false. There is no semicolon there. Okay. Okay. Even. Oh, look at this. This is the thing I need. Whoa. This is actually the thing I'm doing right now. But instead of actually doing something, he's just sending the value to well, I already have that part, so it doesn't matter. Okay, no, the syntax is just fine. I guess I can just say false and call it a day. I don't know why I cannot just continue here to the next one. But I don't know. It doesn't matter anyway. It's the same thing. Okay, so I'm going to append into the even numbers. And I'm getting the even numbers. I guess I'm storing a lot of values that I'm not going to be using anyway. Okay, I'm going to clean that out later. So I got the even numbers now. So I wonder if I can just return the maximum. Is this a function? Max iteratable. Oh, thank you very much. I think this works as I think it's going to work. Like this, maybe? There we go. There we go. How do you like that? Actually, I may like to see if I can create a range function. Range, stop, start. The stop, range function, start, stop, and step. Okay. Let's try this. And what do you return? Range. It creates a range object. Okay. So let's try. I wonder if that's going to be a list. A range object from 1 to 1 million. I wonder if that works. There we go. That's the why. Why is not 1 million? It's not inclusive, maybe? It's not including the end. Huh, interesting. Whoa. Okay, so that works. The thing that I don't really like is the fact that if before I return, let's just say like, what if I want to print the even numbers list? I can certainly do this, but this is the issue. I am storing 1 million values inside memory. It's not okay. The only thing I need to do is to know which value is highest. So I may actually, okay, can I stop this one? Because it's going to take a long time to process. Look at that. It's keep going and on. It's on and on and on. Yeah, that was not a good idea. Okay, it's about to finish. In any second now. Okay, any 3, 2, 1, go. There we go. Okay, it finished. Oh. Okay, it already finished. But the thing is, this is a lot of useless data I don't really need. And it's using a lot of memory. I would consider this a memory leak, actually, if we are straight about this. Well, not a memory leak because, but I am misusing RAM, basically. So I will change this how. What if instead of creating this even number list, and instead of appending it, what if instead of even numbers, I use it as a singular value? Even number. And what if instead of appending a number to a list, I do this? Even number is going to be equals to the current number. If I'm going to execute this statement here. Wait, what's going on? Oh, wait, yeah, because the name changed. And this return is not going to work anymore. Can I type no? False. Okay, so I'm going to assign to this value here, to this even number, a number. Okay. I guess 0 could be considered, well, okay. But the condition is going to change. Instead of just asking, okay, if the current number divided by 2 and the remainder is 0, then do it. I need to ask if whatever is inside even number is highest value. So I'm going to ask like this. And I guess it's like this, and even number. An even number is less than the current number. There we go. Okay, so what I am asking here is, okay, you are going to assign. I wonder if I can. I don't think so. Can I do this and still be syntactically correct? No. I guess this needs to be. No, it's no, because this is an if statement now. What if I do this? No. Yeah, readability is going to be an issue with a ternary operator over here. So maybe I may like to change all of this mess into an actual if statement. So the idea is going to be, let's copy paste this down here. Oh, wait, what? Okay, down here. And I would like to say if I'm going to cut this part over here. If number divided by 2 equals to 0 and even number is lesser than whatever the number is, and remove these cells like that, then I'm going to assign the number. Even number is going to be equals to number. And I don't even need anything anymore. All of this may remain inside the for loop. Okay. You need to be indented inside this. Thank you. So what's gonna happen here is with this for loop, I'm going to repeat the process of, you know what? If the current number divided by 2 is equal to 0 with the remainder of that division is 0, and the whatever value is being held by even number variable is less than number. So basically it's 0 at the start, so any other number, any other positive number is going to win. Then, okay, then, well, do this. Assign to even number the actual value of the current number. Okay, and at the end, just return whatever the even number is. Okay, so in this case, the function is going to work pretty much the same, but it's going to use way less memory. There we go. And I will argue that it's even faster. Okay. Yeah, that's it. That's basically it. I am saving processing power because I'm not appending anything to a list, and I'm not asking a function to navigate through the list and get me the highest value. I'm basically just comparing the current maximum value. Actually, I may like to refactor this. I wonder if I can refactor this thing here. Rename all occurrences. Thank you very much. To max even number. Rename. Wow, nice. It's pretty good for a web IDE, in my opinion. A web text editor or code editor. Okay, let's run again. And that's pretty much my solution for that exercise. It took me some time. I'm not fast, but I'm more worried about being right than being fast.
highesteven. Pause the video here, give it a try. Otherwise, I'm going to go with the answer. So what I want to do here, let's think about this, is I want to make sure that, first of all, we only consider the numbers that are even in here. So maybe what I'll do is create a new list called evens. And evens is going to be an empty list for now, but I'm going to populate this with all of the
Yeah, that was my first idea.
From this. So let's do that. I'm going to say for item in li, if item modulo 2 equals 0, which means it's going to be even, then I'm going to even append the item. So I'm going to add it.
Yeah, that was my first solution, actually.
And then finally, in here, once we have the evens list, I want to find the highest number. Now, you can do this manually and go through it one by one, or Python comes with a nice function called max. And as you can see, we give it an iterable, and it'll tell us what the max number is. In our case, we can just give it evens. And remember, we want to return something from this function. That is, what is the highest number? Well, we want to return whatever the max of the evens is. If I run this, I get 10.
Yeah.
Awesome. Looks like it's working. Now, some of you may have gotten tricked and tried to return inside of the for loop. But if we do this, remember that this still works, but we actually return from the function when we hit our first item. If we had another item, let's say 2 in here, and I click run, we get 2. And why is that? Because I'm returning when we loop the first time through our item, which will be 2.
Yeah.
Is 2 an even number? Yes, it is. So we're going to append. And then we're finally returning max evens, which only contains
on the first
2. So you want to make sure here that the indentation really matters. And if you're returning something from inside a loop, you want to make sure that that's your intended behavior. You usually want to loop through something and then return. So make sure you don't prematurely exit the loop. Nice and simple. Remember, your answer may be different than mine.
Yeah.
There are many ways to go about this. But hopefully, by practicing this, you have a better idea of functions. We now have a great utility function, highesteven, that we can use all over our program. Good job getting this far, and I'll see you in the next one. Bye.
Okay. Wait, what?
Let's say we don't even pass in.
Oh no, I push backwards. Okay. Before continuing, I'm going to get some coffee, so I'm going to be right back soon. Don't worry about it. I'm going to be right back. Let's put some music in the meantime.
close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. On we'll go, finding life along the way, melodies we haven't played. No, I don't want no rest, echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
Se me olvidó.
And we'll grow in number, fueled by them to see the
探索時
horizon, turn
今日サボりやが
thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, and we'll grow in through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
I live inside my own world of make-believe. Kids screaming in the cradles, profanities. Eyes,
And I got my coffee.
eyes covered in ink and bleach. Cross out the ones who heard
Okay,
news and watched me weep.
we're getting back.
I love everything. Fire spreading all around my room.
Yeah, shut up. Oh, little bears. What are you doing? Okay. Yeah, I thought that I didn't share on Twitter. I know that pretty much nobody is watching this live, but either way, I'm saving it for posterity for myself, I guess. Oh, look at that. This looks actually really good. Nice. Okay. I was going to check something here. Did I post a meme? I retweeted a meme and I already posted this. Okay. Yeah, goodbye. Okay, so he did pretty much the first answer that I was going for, but being I don't know. I guess it comes with the realm of taking care of having clean code, you know, and the fact that although the result seems to be the same, I don't see why should I use that much RAM for this function anyway. It may seem insignificant, especially because this is just an exercise, but it does. It sums up to something either way. So that's what I do it. Anyway, where were we? Walrus operator. Okay.
Welcome back. Let's talk about the walrus operator. And this one is a fun one because, well, it looks like a walrus. It looks like this. See? Looks like
Okay.
a walrus.
I
If you
get
know
it.
what that is, it's an animal and it kind of looks like that.
Like
We're seeing this
Pascal
right.
assignation.
So what is this new operator we're going to learn about? The reason I want to teach you this is because I also want to teach you how to learn about new features in Python. For example, this is a new feature. If I go to the Python documentation here, usually what Python does with each new version, they create a what's new in Python document. So you might see what's new in Python 3.9, what's new in Python 3.10. And it gives you a summary of some of the new features added to the language because remember, a language is constantly evolving. So let's say you want to learn about new 3.8 features because let's say the REPL you're on now has 3.8. So it's able to understand the new features like the walrus operator that we weren't able to write before this version. So I would go into the documents and see what's new in Python 3.8. And we see one of the first things is the assignment expression called the walrus operator. So what I would usually do is just read about the summary of what this does, and you can learn about all the new features added in this version. Now let's just focus on the walrus operator because it is useful and also kind of fun to learn about. What this new syntax does is it assigns value to variables as part of a larger expression. So usually you use it in an expression when something is being evaluated.
Wait.
Like in an
I think I remember where I didn't actually share. Did I share it here? I think I did. No. Damn. Okay, so I forgot to share there. Okay. Okay. Let's just share it pretty quickly to LinkedIn. LinkedIn. How do you pronounce that? LinkedIn. What's this? Okay. Yeah, that's the place. I wonder why it's asking me to click twice to do pretty much the same thing, like 3 times. Look at this. There are 2 pages here that don't have a reason to exist. You need to streamline your sharing button here. For Twitter, it's pretty much just create a new tweet, press push tweet, and you are done. Yeah, you need to be simple. Anyway, I'm going to take note of that. Anyway, so let's continue with the walrus operator. It's assignment. I guess we already have assignment though, because we had double equals.
statement, maybe a while statement. So let's play around with this and see what we can do. So let's say we have a string, and we'll call this string hello. Now in here, let's say I want to do a conditional statement. I'm going to say if length of a is greater than 10, I want you to print a string that simply says too long, and we'll say length a elements. Oh, make sure I do that properly. Now if I click run here, I get too long 14 elements. And why is that? Well, because each character here, we have 14 elements because it's greater than 10. This conditional block runs, and we print out too long. We have length of 14 elements. So where does the walrus operator come in? Well, we're writing code and we're repeating ourselves here because we're calculating a length twice. We're using this a variable and doing some sort of a calculation multiple times because we want to use it here and here. But with a walrus operator, I can do exactly that. Remember, if I go to the documentation, it says assigns values to variables as part of a larger expression. So what I can do here is I can create another variable like n, and that says, well, walrus operator. So colon and equals, little walrus there. And this n is going to equal length a. So I'm just going to wrap this in brackets. So we're evaluating this part of the expression, and we're assigning the variable n, whatever the outcome of length a is. So now n is something that has the value of a. So I can replace this with n. And if I run this now, again, same thing.
Whoa. Wait a minute here. Why I cannot do just that in another line?
So again, what we can do is we can assign values to variables as part of a larger expression. For example, if I did n equals length a, well, this isn't going to run. It's invalid syntax, but because of the walrus operator, we can do this now. Let's do one more just to make sure we have it. So let's say in here, we're going to do a while loop. While loop is going to say n, walrus operator, length a. Again, we're going to do the same thing. If it's less than, this time let's do 1. And while this is true, I want to print the value of n, and we're going to reassign the value of a, the variable a, to have one less letter. So I can just do that with the -1 short form here. So we're going to remove the last letter every time we loop through here so that the a variable, the hello, becomes smaller and smaller and smaller until it equals to 1. And once it equals to 1, the while loop is going to stop. So let's just run this. All right, we're getting true, true, true. And we made a bit of an error here because remember the parentheses. We want to evaluate this first. So if I run this again, 14, 13, 12, 11, 10, this is the length of a that's being calculated every time. And at the very end, if I print a and run it, you see that we have h remaining.
Just say
there you have
0.
the walrus operator. You might not see it very often. It's essentially a way for us to minimize doing calculations that are similar, let's say inside of an if statement or a while statement where we want to do something based on a condition and then calculate that value again. But this also hopefully teaches you how to look at new Python versions and learn about new features. There's only a handful of features that get added to the language. Most of the important ones have already been added, but it's also good to keep again.
But I will argue that I can get pretty much the same thing with a simple refactoring like this, for example. Let me say, I'm going to delete all this. And let's say, okay, a equals to hello a lot, okay? And an if statement, well, in this case, I will just assign n is the length of a, and I have pretty much the same thing over here. With this line, I already did the walrus operator thing, and I will argue that it's easier to read. And now I can just use it as he's using it here. If n is greater than then what? Yeah. Print with an F here. Too long. And then he just and elements. Something like that, isn't it? There we go. It's pretty much the same thing. And I will argue that this even reads way better than the walrus operator. But maybe the example is not ideal for this. But what can I do to justify the use of walrus operators? Because it implies that I need to be messy in order to actually use it. I don't know. I may need to check out probable excuses or use cases that justify the use of walrus. I don't know. Okay, what else do you have here? There is a while loop that is pretty much the same thing. Yeah. I don't know. I am in 3 no, that's just no. Okay. Let's say let's use the walrus operator here then. And this. Now what happened? Imbalance syntax. Okay, this returns, and I guess like since this is not this cannot be a statement anymore, or at least not alone. So I'm going to remove this one here. And here, I'm going to use it like this, maybe. There we go. Can I do this? True element is not closed correctly. Let's see how it's happening. The same thing that happened to him. Yeah. Okay. Let's see. Open, 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 close, close, and close. So I need to enclose everything. And the walrus operator needs to be enclosed here too. Okay, that's a little weird. Let's just do it. There we go. Okay, it's working now. Well, I guess. It doesn't look too bad here. I will argue that it makes harder to read. It makes it a little bit harder to read. And I'm not a fan of clever code. I'm more a fan of readable code anyway.
But this also hopefully teaches you how to look at new Python versions and learn about new features. There's only a handful of features that get added to the language. Most of the important ones have already been added, but it's also good to keep an eye out on things as the language evolves, so that whenever you see something like a walrus operator in the code base, you now understand what it does and that it's part of the language. I'll see you in the next one. Bye-bye.
Okay. Scope.
In order to finalize our understanding of functions, we have to talk about scope, another one of our key terms. What is scope? Let's have a look.
Let's have
Scope is
a
something
look.
present in a lot of programming languages. And scope simply means what variables do I have access to? That's it. So what do I mean by that? Well, we've seen this before, right? Where I do print, and then let's say name. If I click run, I'll get an error, a name error. Name is not defined because, well, it doesn't exist, right? And up to this point, we haven't really discussed this, but this is because of scope. What variables do I have access to? The Python interpreter says, hey, what do I have access to? And when we use something that it doesn't understand or it doesn't have access to, it's going to throw a name error or variable is not defined error. And scope in Python has what we call functional scope or function scope. What does that mean? Well, up until now, when we create a variable like total equals to 100, this is part of what we call global scope. That means anybody on this file has access to this total variable. I can use this inside of a conditional block. I can use it inside of a function. It has global scope. But when I say Python has function scope, what I mean is that when we create a function, and let's say we create total as sum, or let's say sum func, and we create total inside of the function, if I print total,
Yeah, it's not going to work.
I get the same thing. Name total is not defined.
It's out of
This is because
scope.
of Python's function scope. Anytime we create a variable, if it's not inside of a function, then it is part of the global scope. We have access to it. But you see over here, we get that red underline, undefined name total. If, let's say, for example, I had a condition, if true, then x equals to 10. If I do this and I say x and I click run, I have 10. Because, well, although I have indentation, the only time I create a new scope, you can think of this as a new universe that we spawn. Well, we can only do that when we define a function like this. So think of scope as a new world that we create. In our case, when we create a function, we create a new world. That anything that's indented inside of the function is its own world that we don't really have access to. We can only use total if we indent print, and it's part of this world. That's what scope is. Who has access to who? So let's take a break here, and I want to play a little game in the next video where we try and figure out who has access to who. I'll see you in that one. Bye-bye. All right, let's play a little game. Can you guess what the output of this program is going to be? I have over here a equals 1, then we create a function called confusion, where we have a equals to 5, and we return a. My question is, when we print a, and when we print confusion, what do you expect to happen here?
Okay.
Take a second to figure out.
Okay, think about it. Okay, there is a global variable a equals to 1. So, and there is a function named confusion. And it does have a local variable called a, just the same, with a different value. And then it returns the value. So my guess is that line number 8 is going to print 1, and line number 9 is going to print 5. It's really not that hard, now that I think about it.
Pause if you need to, and let's find out. 1 and 5.
Yeah.
Is that what you expected?
Yeah.
Let's go line by line. First, we assign a value of 1 to variable a. We then create a function called confusion, and Python interpreter is going to say, all right, confusion function, I know what it is. I'm going to put it in memory. When you need to use me, just let me know. And then it's going to go to line 8. And line 8 is going to say, hey, print a. What's a? Well, the only time that I've seen a is right here. A equals 1. So going to memory, what's a? A equals 1. But then when I run confusion like this, I'm going to say, hey, a is going to equal to 5. And now we return a, which is 5. Okay, what if I change the order of this? What if I go like this? What will happen? If I click run, is that what you expected? Once again, we have a equals 1, then we define the function, and then we print confusion. Now, confusion here is going to assign a equal to 5, and then return a. But why didn't this change? Why is a still equal to 1 by the time we get here?
Because
And
it's
this
a
is because of
different
scope.
a.
What
Scope.
the
Yeah.
Python interpreter does is when it runs the confusion function, it's going to say, hey, a is going to equal to 5, but I'm creating a variable here called a in my own universe. I don't know anything about a equals 1 here. I have my own universe. And after we run this function, then, well, we're done. We've returned the function and it's completely gone. But we never left the universe into the global.
Yeah.
So there's a set of rules that the Python interpreter goes through to check a variable.
I wonder if you can use
First,
global variables
check
inside
both start
functions,
and
though.
local. And what we call is a local scope. A local scope is a scope that's part of...
If they are called the same.
So A is a local scope. It's going to check there. Hey, do I know the variable A? Well, yeah. When I return A, I have A variable defined here. So it starts there. But let's say A wasn't there. Let's say I remove A and I click run here. I get both ones because the second rule is if there's nothing in the local variable or local scope, then number two, is there a parent local scope? In our case, what's the parent of this function? Well, it's the global scope. But we can also do another function. Let's say parent. And parent is a parent of the confusion.
Oh my god.
And here, let's say A equals to 10. Now
going to pick up
return confusion just so we can use it again. And actually
going to return 10.
So let's call parent and click run. All right, let's go through this so it's not too confusing. We have the parent function that gets called. So when we call that, we assign A equals to 10. And we also create a new function confusion. And then finally, we return confusion and actually run it. So we're going to return A, and in here, print whatever the value of A is, which is 10. And why is that? Well, because we first start with the local scope. Hey, does confusion know what A is? Nope, I don't have it in my local scope. Okay, does my parent local scope have it? So it's going to go up a level and say, hey, does parent function know what A is? Yep, I have A equals to 10. So it's going to print that. The third rule, or the third order, is global. And global is what we call the indentation of nothing. It's this file, right? Whatever the file has, that is global. In our case, if A equals to 10 doesn't exist here, there's no local, there's no parent local, and I click run, it checks the global scope. And then finally, there's one other rule, and this is number 4, and it's a tricky one. And this is what we call built-in Python, or built-in Python functions. So Python comes with predefined functions, such as, well, the sum that we talked about before. This sum, let's say just give it 5, is going to check, or actually, let's not give it anything. Let's just do sum here. When I run this, I get built-in function sum. Now, how did it know what this was? What this variable at the end of the day was? Well, because it said, hey, do I have sum inside of this universe? Nope, I don't. Okay, do I have sum in my parent scope? Nope, I don't. Okay, do I have sum in global? Nope, there's nothing sum in here. And then the final thing it's going to check is, hey, is sum some sort of a built-in Python function? Yep, Python actually gives us sum, so you can use it, so it doesn't error out. And this is the scope rules that the Python interpreter follows. Very, very cool. There's still a few more things that we need to learn, so I'll see you in the next video.
Global keyword. I get it.
Let's try and answer some questions.
Just what I asked
For
here.
example, what about parameters? If I do parameter, let's say b here.
Yeah.
What is this parameter? When I use b like this, so let's say print b, and in here I'll run confusion with, let's say, the number 300. If I run this,
yeah, it's going to print 300.
And that is because b, the parameter, is part of the local scope. That is, it's part of this. So parameters are considered local variables. We're able to use it inside of the function, but we can't use it outside of those functions. Technically, when we define the function, we let the interpreter know, hey, b is going to be a local variable. Okay, what about this? What if we have this a, but I want to make sure inside of my function that I'm actually referring to the global a? Is there a way for us to just use this value without creating a new variable? Well, let's use a better example for this. Let's say I wanted to create a counter. So we'll have total equals to 0. And then in here, I'm going to say define count. And this function is going to say total plus equals 1. So we're going to add every single time. When we add count, it's going to increment 0 by 1, and then 1 by 1, so on and so forth.
Okay.
So we're going to return total at the end of this. Okay, so if I run here print count, let's see what happens. I'm going to hit run, and I get an error. Local variable total referenced before assignment. And that is because, well, count doesn't know about total. You're trying to use total, but we haven't assigned anything yet. But we want the total from the outside world to run. Because if I just do total equals 0 here, and I run count, that's great, I get 1. But what if I wanted to run count multiple times? What if I wanted to run count, let's say 3 times? So that the count total will be 3. So let's do print on the last one here. And I click run. I still get 1. Because every time we run the function, we reset the total to 0. That's not very useful, is it?
Yeah,
so
no.
one way that we can fix this is using what we call the global keyword in Python. And global says use the global total if it exists in here. So that instead of having to create a new variable, I can use the global variable. Check this out.
Yeah.
Well, I get an invalid syntax. And that is because we first have to say global total is going to be used in here. And then we can say total plus equals 1. If I run this.
Oh, okay. It's a declaration of use first.
So global is a way for us to access this global variable.
But
I argue that this is actually not a good way of doing things.
Yeah,
because
no.
it can get really confusing when you start adding globals and all these different universes are accessing
global
each other's
total,
variables.
and then I use
better way
total.
of
But
doing
what
this
if
is
I
something called
have
dependency injection? And this is a simplified version of it. But the idea is that instead of accessing variables outside of the function like this, which can get really, really complicated as files get bigger and bigger, is to do instead this. Total. Like this. We create a parameter, and then we pass in that parameter or argument in here. But as you can see, it's still 1 because by the time we print the third total, well, this never changes. This is a global 0.
Yeah, it doesn't change.
So instead, we can do something like this. We can say count total.
So it creates a copy.
Again. And then count again.
Oh, no.
If I run this, I get 3. And I know what you're thinking. This is completely insane.
Yeah,
It's confusing. Look at all these brackets. But let me show you what we've actually done. We're able to detach the dependency or the effect that this count function had on the outside global scope and instead just focus on its health. All we needed to do was say, hey, I want you to give a count with total of 0.
Okay, let me try something. Okay, let me try something really quickly here. Okay. Okay, let's say total equals 0. And I have a function called, I don't know, sum or add maybe. And it's just going to ask a number. And I'm just going to return total plus equals number. But the thing is, I may like to affect permanently the value of total. No, for example, add 3. Oh yeah, I cannot do that. Yeah, I cannot do this. But I might do this first. Total plus equals number, and this is going to be an issue because a local variable total is defined in enclosing a scope on line 1, referenced before assignment. Local variable total assigned to but never used. Yeah, this is not. So what happens if I do this then? If I say global total, oh wait, it's wrong. Okay, there we go. Now what? Invalid syntax. So that's what he's referring to. I'm going to be using global total. And now I assign in, I'm plus equaling this. Okay, so let's do that. Oh wait. In the end, I'm going to print total 3. That's fine. What if I repeat this several times? $15. $47. Okay, so I am with this and using, but what if the thing is, I thought that I could use global variables and local variables named the same inside the function. I guess it's not because what happens if I well, it will go against good programming, you know. Total equals to 1, but this one is a local version and it's not going to work anymore, I guess. There we go. The name total is assigned to before global declaration. So I guess there is no way to use a global variable and a local variable that share the same name. It's a shame, but I never use it anyway, so who cares?
And then after that, this is going to evaluate to 1. And then we do count total of 1 plus 1 is going to equal to 2. And then count 2 plus 1 is going to equal to 3. And this way we're able to still do our count without having to use that global keyword, which I would argue is nicer. Mind you, if this is your first time seeing this, it can get a little bit tricky. But at least this way you know that there's different ways of doing things. One other word I want to show you is something called non-local. But for that one, let's take a break and I'll see you in the next video.
Non-local.
Oh boy, there's some code on the screen, and it looks terribly confusing. This is an example of a really convoluted, complicated function that you would never write, but it'll be good for exercise purposes. And we're talking specifically about this right here, called non-local. It's actually a new keyword in Python 3. And as you can see, my REPL doesn't even notice it, so it doesn't even highlight it in blue because it is a new feature. But I do want to talk to you about it and let you know what it does. The non-local keyword is used to refer to this part, this parent local. It's a way for us to say, hey, that is not a global variable, but is outside of the scope of my function.
Scope of my function.
So based on that definition, try and pause the video and see what this function might do.
Okay, let me see. There are two functions, one outer and a nested function called inner. X equals local. Def inner non-local X. So basically, instead of global, I'm saying use the X variable, which is assigned to a local string, I guess. Okay. And then reassign it to non-local. Then print inner. Okay. It's going to be equals to whatever is holding X. Okay, that's defining the function. And then in the outer function, we are going back to the outer function. We execute inner. Okay, we print inner. And then we print outer. But outer is going to print non-local too. And finally, yeah, because we're printing this in outer. And we're executing outer at the end. So we are going to print the same message twice.
Run it right now and then go through the code. If I click run, this is what we get.
There we go, non-local.
So let's talk about this. We have an outer function, and then we call the outer function. So the Python interpreter is going to go and say, all right, we have an X variable that is local to the outer function. And then inside of here, we're going to define an inner function, another function. And then here, before we even call that, we jump to line 9 and say, all right, call inner function. We come back and we say, hey, line 5, I want to use non-local X. What does that mean? Well, I want to use this X variable because it's non-local. That is, I don't want to create a new X variable. I want to jump up the scope to my parent scope, my parent local, and grab whatever you find in there. As long as it's not global variable, any parent will do. I want to grab that non-local. So now this X is referring to the outer function here. So when we say X equals non-local, we're assigning this new string and replacing this local. So that when we print inner X, we get non-local. But also when we print the outer X, we've modified this outer scope with the non-local keyword, so that becomes non-local as well. If I remove this line and let's comment it out, and I click run, you see the difference now. We have the inner non-local, but then the outer local hasn't been modified because this is a new variable. Again, I argue that this actually makes your code more complicated than it needs to be. So there are special cases where you might want to use this, but if you can, try to make your code predictable where you can avoid using things like non-local and global. Mind you, they are there for a reason because they are useful in some situation. With that said, keep in mind, make your code predictable, make your code clean, and I'll see you in the next video.
Yeah. Why do we need a scope?
I want to address a question that you may or may not have, but it's something that's taken me years to understand. And that is, why not just have everything as global variables? I mean, all this confusion of who has access to who. How easy would it be if everything was just on the main page, all our information, all the data on our global scope so that everything has access to everything? Wouldn't that be easier? And you'd be kind of right. I mean, that would make all this headache go away, right? But you have to remember that machines don't have infinite power, don't have infinite CPU, don't have infinite memory. They all have limited resources. And as programmers, we have to be conscious of what resources we use because sometimes that can cost us money, sometimes that can crash our computers. And scope is a great demonstration of this. For example, this code right here, when this function is run, we're creating technically just one location in memory for the X variable. So we have that bookshelf in our computer that is X, that's pointing to local when we actually call this function. And then when we say non-local here, well, we're saying just don't create another bookshelf for us, just use the one that we already have and assign it non-local. If we didn't have this line, by the time we get to line 7, we've placed in memory X equals to local and X equals to non-local. So we have 2 locations now in memory. Now, this isn't a big deal because, well, in this day and age, we do have a lot of memory. But as programs get larger and larger, this does become a bit of a problem. Okay, but what about a function? I mean, we learned that functions allow us to not repeat ourselves and being able to call outer multiple times. But another good use of functions is that once we call this function and all of this is done, the computer, and the Python interpreter specifically, destroys all this memory. That is, once we finish with the outer function, I can't really call print X here. It's going to give me an error. It's going to say, I have no idea what X is. And why is that? It's because after we call this function, the Python, what we call the garbage collector, is going to say, hey, it looks like we're done with this function. And I see that this X variable, well, in this X variable, we're not going to use because we're done with this function. So I'm going to collect that garbage and then just throw it out. So I'm going to empty that memory cupboard so that other resources or other programs can use that. And that is a really nice feature where Python just automatically removes these for you so that you don't clog up the computer's memory. And that's why scope is useful. We don't have to think about it in such detail like I've mentioned it, but it's nice to know that it's there so that your programs don't hog up a lot of memory and they can run efficiently. This is a bit of an advanced topic, but I did want to include it in here so that you can think about why programs are designed the way they are. All right, I'm going to stop talking now. I'll see you in the next video. Bye-bye.
Okay. What? Imposter syndrome.
Hey everybody,
I
I'm
love
gonna take a quick break here.
exercises.
Go grab a coffee, grab a tea, just take a break from all the learning that you just did. And I want to talk to you quickly about imposter syndrome. It's this idea that you're not good enough, that things are too complicated for you to ever achieve what you want to achieve. You look at other people, at other industry experts, and you say, I will never get there. But it's just a symptom of learning. This idea of you not being good enough simply means that, well, you're just not there yet. Things take time. If you want to learn a valuable skill, well, it's hard work. That's why it's valuable. Remember how you felt on the first day of going to school, first day on a job. It's the same experience. But over time, with repetition, with practice, you get comfortable, you get experience, and you slowly start to lose that imposter syndrome. Now, this idea of an imposter syndrome is great. It means you're doing something worthwhile. So don't use it as a negative. Use it as an encouragement that you're doing something good, that you're learning and you're stretching your limits. So with this break, I want to propose that we do a quick exercise. I want you to stop the lectures, again, grab a coffee, grab a tea, and head on over to our Discord. Now, in our Discord server, if you've used it up until now, that's great. If you haven't, head on over to the server, and I want you to do something that I think is super important to learning. And that is using what you've learned up until now to actually teach someone or help someone. So you can go all the way to, let's say, the coding and courses section and pick a topic that you want to help somebody in. So let's say you go to the Python channel, and in here, you'll have other students that are asking Python related questions. Now you can scroll through here and see if you're able to help someone. Even though you may not have the experience or the knowledge yet, this idea of practicing and explaining what you've just learned to other people, even if you're not 100% certain, actually is beneficial to your learning. Because if you're never teaching, if you're never explaining and vocalizing and showing what you've learned, you'll always be a beginner. This idea of teaching what you learned is a very important concept. So moving forward, as you go through the lectures, anytime you feel like taking a break, hop on over to Discord and help somebody. Our motto here is that we're always kind. We don't judge anybody. We're all just beginners here. We're all learning. So don't be afraid to answer things, because you got to remember, nobody's perfect except for Yoda. Yoda is pretty perfect. All right, I'll see you in the next one. Bye-bye.
Okay. Oh, there is an exam already. Okay, let's see. Oh, this is the end. Whoa. Okay, let's do this right now. Why not? Okay, let's see. What do we have here? And Python exam. Okay. Testing your understanding. We still have a long way to go in the course. However, now is a good time to test your understanding of Python and the Python syntax. Below you will find 2 tests for you to take. Don't worry you don't get everything right. There may be some questions in there that you won't know 100%, because some of them will be covered in the advanced Python sections of the course. Then why are you asking them? The job of a programmer is to use Google when you don't know the answer, which is most of the time. So use whatever tools you have at your disposal to find the solution to your problem. This test will come up again at the end of the advanced Python sections so that you can compare your 2 results, okay? Once done, post your scores in the Python channel in our Discord community, so the community can hopefully congratulate you. Okay, test 1, 25 questions. Whoa, what the? He didn't do the question himself. That's cheating. Can I? Thank you. I just want the questions. Let's try it out. What is the correct syntax to output hello world in Python? I guess this. Next. Question 2. How do you insert comments in Python code? Like this. Question 3. Which one is not a legal variable name? This is legal. I guess this is legal. This is legal. I don't think you may use mid dashes. How do you create a variable with the numeric value 5 equals? Yeah, actually, I think both are valid, because although this is already an integer, I think it's going to return an integer anyway. So both are valid, maybe. What's the correct file extension for Python files? py. How do you create a variable with the floating number 2.8? Yeah, I think both answers are correct, actually. Is float a function? Let's say it does. What is the correct syntax to output the type of variable or object in Python? I believe is print type and x. Okay. I don't remember if it's type of. I don't think so. Okay, what's the correct way to create a function in Python? This one here, def. In Python, hello is the same as hello. True. What is the correct syntax to return the first character in a string? Oh my. The first character in a string. I think it's this one here. Which method can be used to remove any white space from both the beginning and the end of a string? I don't know. It's between trim and strip. To remove white space. Yeah, I didn't get that one. Remove white space Python string, something like that. Yeah, he didn't teach me that one. It's a strip. Yeah, okay, I'm cheating here. It's a strip. Which method can be used to return a string in uppercase letters? I don't remember either. It's a method, so I guess super. Which method can be used to replace parts of a string? Replace, I believe. Which operator is used to multiply numbers? Asterisk. Which operator can be used to compare two values? Double equals. Which of these collections defines a list? Okay, this one here. Which of these collections defines a tuple? This one here. Which of these collections defines a set? A set is not a dictionary. A set is curly braces with single values. Yes. Which of these collections defines a dictionary? This key value pair between curly braces. Which collection is order changeable and allows duplicate members list? Which collection does not allow duplicate members set? How do you start writing an if statement in Python? If, then the condition, then the semicolon. How do you start writing a while loop in Python? I don't actually remember this one. Let's go for the last one, similar to the if statement. How do you start writing a for loop in Python for x in y? Okay. Which statement is used to stop a loop? Break. Whoa! How do you like that? Doop. There we go. This is time for a screenshot. Oh, come on. How do I take screenshots here? There we go. A screenshot. Oh, I can actually share this. Okay. Wow. Okay. Yeah, I am allowed to feel good about myself. I don't care. I wonder if there is an account for that. I don't know. I don't think there is an official account for this. Maybe as a hashtag. Let's tweet those beautiful results. LinkedIn. Okay. No emojis here. What a shame. Okay, never mind. Yeah, I don't care about Facebook. Who cares? Okay, nice. Well, that was fun. Wait, it's already out? Hmm. 2006, 2012. Oh my god. What's a luxury belief? Yeah, what is that? Mm. Oh, okay. Luxury beliefs are ideas and opinions that confer status in the upper class while inflicting costs at the lower class. Yeah, I'm going to tweet about it. Thank you. I'm going to actually cut all that and answer down here. Why not? That's a really good explanation. So basically, um, I cannot have the luxury to believe what the rich guy does. Yeah, I actually understand that. Oh, nice. I should actually get this game, Guilty Gear Strive. I'm being very short on time playing King of Fighter 15, but my next game is going to be that one. There are a lot of fighting games that I want to get my hands on, but just because I'm deciding to basically learn something new, I don't know. Well, let's do it. Who cares? Insert the missing part of the code below the output. Hello world. Okay. Print hello world. Oh, okay. Exercise 2, I guess. Wait, did I submit my answer? Ah, great. Okay, exercise 2. In this example misses indentations to be correct. Insert the missing indentation to make the code correct. Okay. Okay, next. Okay, comments in Python are written with a special character. Which one? Use a multi-line string to make a multi-line comment. Not correct. That's actually a multi-line string, asshole. Okay. Not correct. Are you kidding me, bro? Where is the other input? Oh my god. Well, he's right, but where is the other input? I don't actually see it. Okay, whatever. Create a variable, name, car name, and assign the value Volvo to it. Okay. Create a variable x and assign the value 50 to it. Display the sum of 5 plus 10 using two variables, x and y. Okay, x, 5, guess plus. create a variable called seed, assign x plus y to it, and display the result. Well, I guess that's even easier. Remove the illegal characters in the variable name. Okay, this is one. And I guess it may not begin with a number. And that's it, I guess. Insert the correct syntax to assign the same value to all three variables in one code line. Okay, I guess one variable, two variables, then this is equal. Insert the correct syntax to assign the same value to all three variables in one line of code. Yeah, how do I do that? I don't remember. Yeah, the same value and assign that to all of them. Yeah, I don't know. Whoa, that's nice. Okay, I didn't learn this on the course, but this is a good tip, actually. And kind of makes sense. Okay. What? Well, I already know the answer, so what? It doesn't matter. What? Insert the correct keyword to make the variable x belong to the global scope. Global x. The following code example will print the data type of x. What data type should that be? I guess int. An integer. The following code example will print the data type of x. What data type would that be? Well, in this case, it's a string. So str. The following code example will print the data type of x. What data type would that be? Floating number? A float? The following code example will print the data type of x. What data type would that be? The same thing. It's going to be a list, I guess. There we go. And the same thing, the following code example will print the data type of x. What data type will that be? This is going to be a tuple. The same thing is going to be, what's the object for dictionary? Nothing else? Okay. The following code example, the same thing, Boolean bool. Okay. Insert the correct syntax to convert x into a floating point number. I'm going to cast that as a float. Insert the correct syntax to convert x into an integer. Let's cast x as an int. Insert the correct syntax to convert x into a complex number. I believe it's real? No, I don't remember. Complex, yeah, okay. Never mind. Okay, complex. Use the len method to print the length of the string. Okay, print length x. Get the first character of the string txt. I guess will be txt and the index 0 because that's the index of the first character. Get the characters from index 2 to index 4. LLO. Okay, how do I do that? With the substring thing. I believe it was txt, and I need to store at 2 semicolon and stop at 4. Not correct. 5 because it's not inclusive. I forgot about that. Okay. return the string without any white space at the beginning or the end. Okay. It's with a strip, I believe. A strip. Oh wait, it's a method. So it will be txt.strip. There we go. Convert the value of txt to uppercase. txt.upper. Okay. Convert the value of txt to lower. Well, my brain is getting on the okay. On the patterns here, I mean. Okay, replace the character H with a J. I guess it's replace. Now I'm going to guess this works like in Java. The what and the what with. Okay, the what and the with. Okay, it will be I want to replace H with what? With J. Oh my god! Nice. Insert the correct. I just guessed that one because I remember how that works on Java, and it seems like it pretty much works the same. Insert the correct syntax to add a placeholder for the H parameter. Oh wait. The syntax for the place. Oh, okay, because the format is being given in Python 2. Okay, so this will be, I guess, like this, nothing else, because this seems to be Python 2 formatting. There we go. The statement below will print a Boolean value. Which one? Is 10 greater than 9? True. The statement below will print a Boolean value. Which one? No, false. Because 10 is not equals to 9. Okay. The statement below will print a Boolean value. Which one? Is 10 less than 9? False. The statement below will print a Boolean value. Which one? ABC is not false, so it's going to be true. It's truthy. There we go. The same thing. The statement below will print a Boolean value. Which one? Bool 0 is going to be false because 0 is falsy. Multiply 10 with 5 and print the result. Print, I guess just this. Divide 10 by 2 and print the result. This is quite easy. Use the correct membership operator to check if apple is present in the fruits object. Wait, what? I guess in, because it's an if, and this is a collection. Yeah, I think that's right. Okay. Use the correct comparison operator to check if 5 is not equal to 10. I wonder if Java style, this is a C style not. I wonder if this is going to work. Not equal, I don't think so. Maybe like this? No. Not equals? Okay. Use the correct logical operator to check if at least one of the two statements is true. At least that means it's an OR. Print the second item in the fruits list. Print fruits 1 because it's the second. The first one is 0. Change the value from apple to kiwi in the fruits list. Okay, you will be fruits. Which one are you? Apple is 0. To kiwi. It's like that. Okay. Use the append method to add orange to the fruits list. Get orange. Okay. Use the insert method to add lemon as the second item in the fruits list. Okay, I guess I'm going to be inserting add one. Okay. Wait, what? Okay. Huh? Use the insert method. Okay, fruits. This is a method, so it's going to be here. And I guess I'm going to be saying 1 comma. Is that okay? There we go. Use the remove method to remove banana from the fruit list. Okay. And I guess I'm going to pass the index. Will be 1. No, because I do have more space. Look at this. So probably banana. And it's going to look for the actual value. Whoa, interesting. Okay, use negative indexing to print the last item in the list. Print fruits -1, the last one. Use a range of indexes to print the third, fourth, and fifth item in the list. Okay. The third, 3, 4, and 5. Okay, I guess, how do I define a range here? Like this? 3 to 6, maybe? No. 3 to 5? No. I don't know. Ah, with a semicolon, because it's a range. Okay. Yeah, the third element will be 2, 3, 4. But I need to make it inclusive because it will actually say, okay, you start at 2, 2 starts here, 2, 3, 4. That's what I need 5 to get here. Okay, yeah, this. So range is done by semicolon. Okay. Use the correct syntax to print the number of items in the list. Okay. I will say length and the object. In this case, the list. Use the correct syntax to print the list item in the fruits tuple. The first item, okay. Print. It's the same thing. It doesn't change just because it's a tuple. Use the correct syntax to print the number of items in the fruits tuple. The same thing. It doesn't change because it's a tuple. Just the same as in list. Use negative indexing to print the last item in the tuple. The same thing. How many are there? Oh my god. Use a range of indexes to print the third, fourth, and fifth item in the tuple. I guess it's the same. Check if apple is present in the fruit set. And just the same thing. It doesn't matter. It's the same question. Use the add method to add orange to the fruit set. Oh my god. A pen? Oh no, it's called the add. So orange. Yeah, I'm not typing that again. Use the correct method to add multiple items, more fruits, to the fruit set. Okay. To add multiple items. So I use add to add more to the, okay. So Multiply to the fruit set. Okay. I'm going to add into the fruit sets. I'm going to add, and maybe I can just add a collection. Like this? No. No, because I'm missing characters here. Why? Append? That is the name. Because this is a list. So basically, I guess in the case of sets, I need to use append maybe at the end. Not correct. I don't think it's add. Which one is it? Update. Update. Okay, I may need to check this one out because it didn't occur to me. But anyway. Use the remove method to remove banana from the fruit set. I guess it's the same thing. I'm missing a character. Oh, wait. Use the discard method to remove banana from the fruit set. Oh, so sets and lists and tuples use different names for their methods. Oh, it's discard. I wonder why do they have different names for the same thing. I understand they are different different objects, but I don't know. Use the get method to print the value of the model key of the car dictionary. Okay. Car. And I believe it's dot. Wait. Use the get method. Yeah, dot get. And the there we go. Change the year value from 1964 to 2020. Okay. Car dot year. Now it will be set. Here. Oh no. It's not that. How do I change the value of a key inside a dictionary? Well, here it's going to be 2020. It's not a big deal here. But here I guess it's going to be car, then set. I would guess set and year, but it doesn't fit. Year surrounded by, I don't think so. No, how do I do that? Oh, like an index formatting. Get it now. Thank you. Yeah, I'm doing that. Car, no dot, and between the index brackets, year. The name of the actual index is year, okay. And the key value per color, red to the car dictionary. Okay. Car. I need to add the key value per add maybe? No, because it's going to be yeah, indexes. It will be color semicolon red. No, will be like this. What? What? Why just a one? I don't get it. color red, but I don't have enough space to write, to type that one. Oh wait, this equals doesn't belong there. There we go. Yeah, okay. I'll be right back. I need to go to the bathroom really quickly. Okay, and I'm back. There we go. I'm not using the headphones right now, so let's continue. Okay. I forgot about this completely because I used to do a lot of assignments to dictionaries before when I was working for the bank, and I just forgot how to do that one. Oh my god. Yeah, and the key is color. And the value is red. Yeah. Use the pot method to remove model from the car dictionary. Car pop, and I guess I need to pass him the model. Use the clear method to empty the car dictionary. You're a method. Okay, if else. Oh no. Print hello world. How many are there? Oh my god. There are just so many. Well, let's see. Let's just push through because I want to take a break. I need to take out the trash, and I've been here for 2 hours already. So let's continue. Let's just push through this. And it reads. Actually, I don't want to see this because it's going to make me anxious. Okay, print hello world if A is greater than B. If A is greater than B, print hello world. If A is greater than B. Oh wait, I forgot about the semicolon at the end. I always do. Print hello world if A is not equal B. It's not equal to B. Yeah, it's good to practice the semicolon at the end. Print yes if A is equal to B, otherwise print no. Okay. What? Print yes. Okay. If A is equal to B. Okay. Otherwise. Else. Do I have to print a semicolon here? Okay, I missed that one. If print 1 if A is equal to B. Okay. Print 2 if A is greater than B. Otherwise, print 3. I wonder if I've been typing this semicolon at the end of else's. I don't remember that one. Print hello if A is equal to B and C is equal to D. Okay. Print hello if A is equal to B or if C is equal to D. So I guess it's or. I'm not wasting brain cells on that one. This example misses indentations to be correct. Insert the missing indentation to make the code correct. A tab over here. Use the correct shorthand syntax to put the following statement in one line. Okay. I guess the shortcode syntax. I guess do this if 5 is greater than 2. Not correct. Show answer. What? This is retarded, but anyway. Okay, I'm going to believe you. Well, actually, I just learned something here. Something useful, I may like to think. So basically, if you only have one line, whoa. Okay. If you only have one line, You can just put everything on a single line. That's it. Use the correct shorthand syntax to write the following conditional expression in one line. I guess like this. Then how? Print yes if. Now you are using the ternary operator. Come on. Okay, print yes. Oh. I'm just going to copy paste it. I don't care anymore. Print I as long as I is less than 6. Can I do something else? Stop the loop if I is 3. Okay. Is equal to 3. Let's break. Okay. In the loop, when I is 3, jump directly to the next iteration. Print a message once the condition is false. Well, oh, I forgot about the semicolon. Loop through the items in the fruits list. Semicolon. In the loop, when the item value is banana, jump directly to the next item. Use the range function to loop through a code set 6 times. For in range. 6. Exit the loop when x is banana. It's the same thing. Create a function named myFunction. I'm missing an F. Execute the function named myFunction. I'm just going to do this, dude. I'm not in the mood. Inside a function with 2 parameters, print the first parameter. Let the function return x parameter plus 5. Return x plus 5. If you do not know the number of arguments that will be passed into a function, into your function, there is a prefix you can add in the function definition, which prefix is going to be an asterisk. If you do not know the number of keyword arguments, well, the same thing, but with keyword arguments. Create a lambda function. I don't know what this is. Let's try it out. I don't know. Lambda A returns A. So this is basically single line function, anonymous functions on JavaScript. Yeah, this is basically anonymous functions on JavaScript. Yeah. Classes, inheritance, and models. Yeah, I'm tired. I'm going to take a break. I need to take out the trash. I'm going to be back later today to complete this course. Let's see. Where were we? We just finished section 4. I may like to complete section 5. It's 1 hour. Yeah, I can do that today. Especially because I'm going to skip this. Maybe this. This. I'm not skipping this. Maybe I should skip Sublime Text. I'm going to skip this. Optional terminal commands. Maybe I'm not skipping that one. Item setup. I'm not using that. Using the command line terminal. Visual Studio Code. PyCharm. I don't think so. Code formatting PEP 8. Quit now Jupyter Notebooks and section review. And I just skipped some of the content. I'm going to be back later today to complete this one here. It's just 1 hour. I just finished a 3.5-hour section. Well, not today, but you get me, okay? So I'm going to take a break. I'm going to take out the trash. I may like to stream video games. I want to keep playing a little bit of King of Fighters 15 and see how I fare against online, maybe. But who knows? Maybe I should troll a little bit on Twitter. Who knows? Well, oh wait, new video. I'm going to be watching this while I'm doing the chores. Oh, here goes. Oh wait, no, 90 minutes. So it's not going to be right now. Yeah, why not? Predictive text and stupid games. Well, I'm leaving. Thank you for watching, for listening. Oh, look, he's not disabled at all. It's a miracle. He's not disabled. He can actually fight. Look at that. What the fuck? What's going on? So he was basically a scammer. Okay. Well deserved, I guess. What? Oh my god. I feel attacked. Oh shit. I feel attacked because funny enough, I've been consuming all of my my courses at 2x speed, double speed. So because I feel like I'm saving a lot of time, basically half. In the thing that watching this 3.5-hour section actually cost me just pretty much like just half, basically close to 2 hours maybe. So yeah, I don't know. Okay, I'm going to read this one. Sounds interesting. Let's put this one. Yay. I'm going to read this one. Yeah, why not? Well, thank you for coming in and see you later today.